So good morning, everyone, and welcome to the start of this program, which is the 3 months full-time structural engineering training program that we are going to start from today. So I hope my voice is audible. Yes, okay. All right. So first of all, I would like to me and Akanksha both, we would like to thank you for joining this program. So this is the first time that we are conducting such a program, and all of you have shown great response. So thank you for that. Uh, I can assure you that we will have a great time doing these projects together in the months to come, and it would be a new learning for all of us. You will also learn some things new. We will also learn new things with all of you. So I'm sure we will have a good time during the next 3 months. All right. So I will just run through a small presentation, and then we will straight away go to the AutoCAD drawing, and then we will look at our first project. Right now, all of you are on mute. After we finish whatever I have to tell for the day, then we will unmute you, and uh, we can have an interactive round after some time. Okay. So right now, all of you are on mute. If you want to communicate something for the time being, you have to write it in the chat box. After that, time will be given for uh, interaction, any interaction that you want to do. Okay. All right. So what are we basically going to do? We all know by now that we would be doing 4 projects during this course, during this program. We will start with a residential bungalow. So it would be an independent house, independent bungalow that we would be doing. That would be our first project. Then we will move on to a multi-story commercial building. You know by now that this is going to be a hotel building. You can see the screens, right? I hope the screen is visible to all of you. And yes, then we will move on to an industrial building. So this is actually a soda plant. Soda, not the soda water soda, but soda chemical compound manufacturing plant. So this is going to be a soda manufacturing plant, and it is going to be a unit of that plant. An entire plant will have several units. This is going to be one unit that we are going to do when we take up this industrial building. And then in the end, we will do a multi-compartment, large capacity liquid retaining tank. So this is going to be an ETP. ETP, E stands for, what is E? What is the E in ETP? So E stands for effluent. Okay. So this is going to be a large scale effluent treatment plant. What do we mean by effluent, and how it is different from sewage? Just to clarify, you might have heard these two terms, isn't it? One is sewage and one is effluent. So what is the difference between these two terms? Anyone? So sewage basically will include the mostly the human waste. Okay. Sewage will include mostly the human waste, and you can say the kitchen waste, etc. When water, or when these wastes are to be these wastes together are called as sewage. Kitchen waste, human waste. In general, we can call it as a municipal waste. Okay. In general, we can call it as the municipal waste, a waste that comes out from your general city. All right, that is the municipal waste is called as sewage. And what is effluent? So effluent basically stands for the industrial waste. Okay, so effluent stands for industrial waste. So waste coming out of an industry, waste water, you can say waste water coming out of an industry, is called as effluent. So we would be doing this ETP, effluent treatment plant design, as our fourth project. So in this way, we would be doing these four projects. The order of doing these projects would be 1, 2, 3, and 4. So I have taken them in this order. It does not mean that the difficulty level is also in this order. All right. You should not confuse it this way, that as I am taking the project in these order, this is going to be the difficulty level. So that is not going to be the case. Every project is going to be equally challenging for us. All right. Sometimes these small projects like this, a G+1 project like this, sometimes is more challenging than, let us say, a G+5 or G+6 project. Okay. So you should not think it this way, that residential bungalow is going to be easy and industrial building is going to be tough. Every project will have its own unique challenges. Okay. We will be seeing to them during the course. Good. So what will be the journey, or what will be the steps involved in every project that we do? So can anyone give any idea what they think are going to be the steps involved? Yes, anyone? Hello. What do we think would be the steps involved in doing the projects that we are going to do? What will be the first step? Okay, if I ask you what is the input that you as a structural engineer will want, what is the input that you as a structural engineer would want when you have to start any project? Let us say a client comes to you and gives you, appoints you as a structural consultant, or let us say you are working at some office and you have been given a project. So what is the first input that is going to be given to you? So the first input that would be given to you would be, yes. So the first input that we would be given would be the architectural drawing. Okay. So architectural drawing will be the first input that is given to us. Now, generally, as a structural engineer, we may not be preparing these architectural drawings. Some structural engineers who are involved in planning and architectural work also, they will themselves prepare these architectural drawings. But we, for this program, we will not be preparing architectural drawings as such. We would be using them as inputs. All right. So architectural drawing will be our starting point. We will get this. Once you get your architectural drawing, what will be the first step that you will do with this architectural drawing? So you will not straight away go for modeling or analysis, etc. We will, of course, go for the initial planning of structural framing system. Okay. What do I mean by this? Initial planning of structural framing system. So this means that we will have to, yes, anyone? So we will have to first see that what type of structural system we are going to adopt. What is the structural system that we are going to adopt? That is going to be the first question that we have to decide on. Okay. So what is the structural system to be adopted? So you can have multiple structural systems. You can have RCC beam column as your system, isn't it? RCC beam column as your system. You can have a flat slab as your system. You can have a RCC column with, let us say, instead of flat slab, you can have a grid slab. You can have a waffle slab. You can have a PT slab. So all these structural systems first have to be decided. Okay. So we will decide what is the structural system that needs to be adopted. Once we decide, then we will work out, as Mr. Virat is saying, we will work out some initial beam column positions. Okay, that has to be worked out. So as a structural engineer, this is going to be the most important job that we have to do. All right. See, modeling, which is going to be the next step, modeling of superstructure on ETABS or modeling on any other software. This is not a big challenge. All right. This is not a big challenge. This anyone can do. You do not require structural engineering knowledge to prepare a model on ETABS, but the initial planning and the initial adoption of structural framing requires good common sense and good structural engineering knowledge. All right. So this is going to be very important step. The first step is going to be extremely important. So once we work out a structural framing system, then we will move on to modeling of superstructure on ETABS. So these are the steps that we would be adopting for each project. All right. First, finalization of, or I would say, initial adoption of structural framing system, whatever structural framing system you decide. Then we will move on to modeling of superstructure on ETABS. Then we will proceed to load calculations. The load calculations, we will involve gravity loads and lateral loads, whichever or whatever is applicable. Okay. Once we calculate the load, then we will apply the load on the model. Once we do the load application, then we will go for analysis of superstructure using ETABS software for this program. Then we will do design iterations to finalize the optimum design. This thing will be discussed. All these steps will be discussed in detail as we move ahead. Right now, I'm just giving you the step-by-step approach that we are going to adopt. Once we do the design iterations and once we finalize the optimum sizes, then we will move on to find out the reinforcement. To find out the reinforcement, either we will use the software outputs or we will use some Excel sheets. Then we will go for foundation design. So till now, we are just doing superstructure. Till this step, we are doing the superstructure. Superstructure means above ground, whatever we provide, that is usually called as superstructure. From here on, we will move on to substructure. Substructure means whatever is below ground, generally foundation systems. So that is called as substructure. So we will move on to substructure. In substructure, we will export the reactions from our superstructure to safe software. Once we export the reactions to safe software, then we will do the modeling analysis of foundation using safe. And finally, we will finalize the foundation sizes and reinforcement, again, either using software results or spreadsheets. Once we do this, then we will move on to, I think, yeah, one step has to be added over here. Then we will move on to drawing development using AutoCAD. Okay, using AutoCAD. This step was left over here. So we will move on to that step. And finally, once our drawings are ready, then we will go for BOQ, bill of quantity, and in the end, we will prepare the design calculation report. So all our 4 projects that we are going to do will follow this path. So I have explained you in 5 minutes. We would be spending 15-20 days for each project. We will be spending more days on the initial projects, and then as we move ahead, our speed will increase. So our time will then reduce naturally. All right. So this is going to be the steps that we are going to adopt for each project. I think these steps are pretty clear to anyone. If anyone has doubt on any of these steps, they may put their query in the chat box, or we straight away move ahead? Yes, anyone having any doubts? Okay, good. Very good. So now, yes, Mr. Oves is asking, are we going to do any manual calculations? We will do. We will do. As and when required, we will do manual calculations also. Manual calculations are necessary, isn't it? You have to know manual calculations uh, for structural designs. So we will be doing manual calculations wherever they are required. That does not mean that we would keep on doing manual calculations, because now we have this tool in the form of ETABS, isn't it? So this ETABS is going to be our tool that we are going to use. For example, if I have a calculator, then I do not use, let us say, log tables to do mathematical operations, isn't it? I use calculators because the calculators are much more convenient and the calculators give me much more quicker results. So I will not rely on log tables to do my mathematical operations. Similarly, if I have ETABS, most of my things which are being calculated by ETABS, I will rely on them. If I have to, let us say, do manual calculations for some things, we will do manual calculations. All right. Generally, see, I will answer this in greater detail. Generally, there are two parts to any structural project. One is the analysis part, and one is the design part. By design, whenever I will use the word design, basically we mean to find out the, I would say, finalize the concrete size, okay, and find out the reinforcement. This is what we generally mean by design. So this design, okay, before that, analysis. What is analysis? Analysis means finding out the finding out the actions like moment, shear force, axial force, okay, torsions. So finding out actions is called as analysis. How do we find out these actions? By using some analysis methods. All right. What are the analysis methods that we use? So you might have heard about the different analysis methods that we use, starting from, let us say, conjugate beam method. There were a lot of analysis methods that we have learned in our engineering, if you remember. So we used to use some conjugate beam method. Then we used some slope deflection method. Then, if you remember, we used, of course, moment distribution. Then we used, I think, I even don't remember. We used the flexibility matrix method, the stiffness matrix method. So all these are analysis methods. Okay. So these have certain assumptions. These have certain inbuilt, I would say, limitations. Each method has some assumptions and some inbuilt limitations. So there are two parts, analysis and design. Analysis involves calculation of these actions. So this part, analysis part, usually we will depend on the computer, or we will depend on the software to do it for us, because you will understand that this is, there are a lot of calculations and a lot of mathematics that is involved. So we will depend on the software to do this part. Am I clear? So we will depend on software to do this part for us, to do the analysis part. When it comes to design, by design, I mean, as I said, finalizing the concrete sizes, RCC sizes, and then finding out the reinforcement. So these two steps for me, I would be calling them as design. So this design, how do we do design? Once I have, let us say, a bending moment, How do I find out the beam size and reinforcement? Tell me. How will I find out the beam size and how will I find out the reinforcement? Anyone? Yes, how do we find out this AST, or how do we find out what size is to be finalized? What do we do it for that? Hello. So basically we will be using some standard algorithms, isn't it? We use certain standard algorithm, means a certain step-by-step process is what we have to use. Now, who gives us these algorithms? Who will give us these algorithms? So we will have to follow some standards. So generally we will have some design standards that we will follow, which give us the algorithms to find out the reinforcements or to find out the beam size, etc., from these design actions. So generally you will see the codes and the textbooks calling them as design actions. I will take this to whiteboard. Wait, it would be better. Are you able to see this whiteboard? Yes. So one part is analysis and the other part is design. I just want to give you a brief idea about this. So design means finding out the uh, concrete size and finalizing the reinforcement. This is what I mean by design. And analysis means calculation of various design actions. So those design actions, broadly, there would be 5 design actions that we basically are interested in knowing about. So those 5 design actions are, anyone? Those 5 design actions would be bending moment, shear force, axial forces. So if I break down axial force into 2 parts, it would be tension, it would be compression, and torsion. So any structure, whether it is the tallest building in the world, or whether it is a G+1 structure, whether it is the longest bridge in the world, or whether it is a small culvert that you are doing, any structure that you do, the elements basically will have these design actions, isn't it? Bending moment, shear force, tension, compression, or torsion. So calculation of these design actions comes under the analysis part. So for analysis part, we have a lot of methods, as I just explained. When we, because it is very difficult to do these, do a lot of mathematics by hand calculations, we rely on the software to do it for us. So in this case, we will be relying on ETABS and or SAFE to do the analysis part. Okay. So these softwares basically use the matrix methods. Why do they use the matrix methods? Why do the softwares use the matrix method? Because for computer programming, if you know computer programming, you will basically agree with me that for computer programming, matrix methods are the most simplest to do, isn't it? Therefore, all the softwares that you see, they, in some way or the other, they use the matrix methods to do the analysis. So after analysis, we will get these outputs. Once we get these outputs, then from this design action, how do we find out? How do we do the sizing? How do we find out the concrete size required? And how do we find out the reinforcement? So this I was explaining you in the last slide, that we use some algorithms. Algorithms means standard step-by-step protocols that are given to us. So in our case, these algorithms we will get from the design standards, isn't it? So design standards will give you the algorithms that we have to follow. Am I clear? Okay. So generally you will see that the design standards do not talk a lot on analysis, isn't it? The design standards will not talk a lot about analysis. They do talk about analysis, but not very much. Mainly they focus on this part. Mainly the design standard will focus on the design part, which means finding out the concrete size required and finding out the reinforcement. So this design part we will try to do manually also. In most of the design offices, if you see, many people, what they do is they will do it manually. By manually, I don't mean they would be doing hand calculations every time. By manually, I would mean that they would be taking these outputs, they would be taking these design actions that they get from this software, and to find out the reinforcement, etc. They will take use of what? So they will take use of some spreadsheets. Okay, so they will develop some Excel spreadsheets. Okay, and they will use these Excel spreadsheets to find out the concrete size and reinforcement required. So you will appreciate that this design, because it is an algorithmic process, because this is an algorithmic process, it has to follow the same process every time. What I mean by this is, let us say your bending moment is 100 kilonewton meter, for example. Okay, and you have to design a beam which can take this 100 kilonewton meter. So you will be following some steps, 1, 2, 3, and finally you get some output. The output would be the beam size BD, and output would be AST, isn't it? Now, if my bending moment becomes, let us say, instead of 100, if my bending moment is 1000 kilonewton meter, will these steps change? What do you think? Let us say for a small structure, if you are doing a very small structure, a small beam you were designing, a 3-meter beam, and the bending moment was 100 kilonewton meter. If instead of it, your bending moment now becomes 1000 kilonewton meter, do you think that the step-by-step algorithmic process, will it change? Will this process change? So this process won't change, isn't it? This process won't change. Therefore, we are calling it the algorithmic process. So this process, these steps 1 to 2 to 3, the process remains the same. Okay, the process remains the same, irrespective or notwithstanding any change in these design action values. So because this process remains the same, it is very easy to automate this process. I hope you are understanding. Because the process remains the same, whatever be the input, whether the bending moment is 100 or the bending moment is 1000, you have to follow these steps. So because you have to follow these steps, the process and the process is remaining the same, you can automate this. By meaning, what I mean by automate is, uh, I, I I hope you understand automate, isn't it? You can automate this. So how do we automate this? We automate this either by using the software itself. So your software like eTabs, Safe, or StatPro, whatever software you are using, they are able to do this design process also. We all know this. So these softwares, what they do is, they will take these design actions, they will uh, run these standard algorithms based on whatever design standard you have adopted, and even your softwares will give you these outputs. If you don't want to use these softwares to give you these design outputs, if you don't want to use these softwares to give you the reinforcement output, what many people also do is that they will take the design action results and then they will use some tools like Excel spreadsheets, or you might have heard about some post processors like RCDC, etc., to find out the reinforcements. All right. Have I made myself clear? Okay. So So therefore, to answer what Mr. Oves was asking, that where do we do manual calculations? Where will we use manual calculations then? Yes, after this discussion, if anybody asks you in future, where do you use manual calculations more? So we will say that we would be using manual calculations more for the design part. Okay. Why we are not going to use manual calculations for the analysis part? Because it is very difficult to do manual analysis for bigger structures. For a simple beam, you may do manual analysis, WL square by 8 moment, or let us say shear WL by 2, whatever. But we cannot expect to do manual calculations for big structure as far as analysis is concerned. Okay, I hope this part is clear. Yes. Now many people, what they, or many structural firms, many structural engineers, even we also, when we are doing projects, many times what we do is that we take these design actions, we take the design actions, let us say from ETABS results, ETABS or STAD or SAFE results. So we will take these design actions, bending moment, shear force, tension, compression, torsion, etc. And people will use, either they will use some Excel sheets, or there is a post processor called as RCDC, etc., to find out the final ASTs, isn't it? This is a standard practice that is adopted by many of the structural engineering firms and many of the structural designers. So why do people do it? Because there are more controls that your RCDC gives you as far as STAD is concerned. Okay, because in STAD there are a lot of things that you cannot control in the final design. Okay, there are not enough parameters that you can assign to STAD while doing the design. So many people will prefer RCDC. Many people will prefer Excel sheets. So they will not use RCDC also. They will take the inputs from here. Sorry, they will take these outputs. These outputs will be used as an input. It will be put in this Excel sheet, and our Excel sheets will give us the AST values, let's say. Okay. So Mr. Virat is asking why designers do not use the software design. Many designers do use, many designers may not use also, because there are some problems that ETABS and STAD also has. Okay, there are some design problems that you see in STAD and ETABS. I will tell you what those problems are as we move ahead. But because of those problems, people will just take the design actions and then rely on some Excel sheet or post processors like RCDC. Srinivasji is asking, can we rely on RCDC results? Yeah, you can rely, but for better clarity, I would say as a first approach, as a first learning, you should not straight away start with RCDC. Okay, it does not give you that feel for structures because that software is doing something internally. So unless you are not very thorough, you should not straight away go to RCDC. Try to do it yourself. Okay, is it clear? All right, good. Moving back where we left. So this is going to be the step-by-step approach that we are going to adopt. Any further confusion, question you would like to ask? Okay. Good. So now let us go ahead then straight away without wasting any further time, because we have to be very focused in this program. We would straight away jump into this first project that we are going to do. So as I have told you earlier in the introductory session also, that this is going to be a residential project that we are going to do, residential bungalow to be precise. that we are going to do as our first project. So what I will do is I will stop this presentation and we will straight away go to the AutoCAD drawing. Right. So this is the, just give me a minute. I'll be back. Yes, can all of us see this AutoCAD drawing? So this is going to be the first project that we are going to do. All right. Straight away we have started with this. So what is this? Let us quickly go through the plans that have been given to us as an input, and then we will discuss them in detail. So this is the plan. This is the ground floor. You can see the title, ground floor plan. Then this is the first floor. This is the first floor plan. And this is the second floor plan. Actually, this is your terrace level. So this would be called as what? G plus. This would be what? G plus. So, hello. Yes, you have a ground floor, and then you have a first floor, and you have a terrace level. So we would be calling it as a G plus 1 structure. All right, this would be the G plus 1 structure that we are going to do. All right. Generally, independent bungalows, usually you will see there G plus 1, at the max G plus 2, but even G plus 2 are rare. Usually residential bungalows are G plus 1. All right. So this is going to be a G plus 1 bungalow. Now, when you get this architectural drawing, what is the first thing that you should do? Let us say your client has given you. What is the first thing that you should do? Yes, first thing. You have been given this drawing, isn't it? So what is the first thing that you will do? The first thing always should be to study the plan. All right, or study the drawing, whatever has been given to you. Of course, our intention is to finalize or to decide the structural system. As I had mentioned in this slide, that whenever you get any drawing as an input and when you have to start your project, the first step always will be to finalize the structural framing system. But before you can finalize the structural framing system, you need to first study the plan. Okay. So first thing, very extremely important, is to study the plan. I would not say only plan, study the drawing. Okay. Study the drawing. Your drawing may involve plan, sections, elevations. So your drawing may involve plans, sections, elevations, etc. Okay. In this case, we have only been given plans right now. Okay. For this project, we right now do not have the sections and elevations available with us. But usually you would be given sections and elevations also. So you need to study the drawing and study the drawing in great detail. I have seen many structural engineers or many design engineers, the biggest problem they have is that they do not study the plans or study the drawings thoroughly. Okay. And they straight away rush to do, let us say, to finalize the column position or straight away they will rush to do the model on ETABS or STAD, etc. So that is not the way you should proceed. You should in detail study the drawings. Extremely important step. And you should try to not just study but also understand. You should also understand the drawing. Okay. See, right now this project is easy. Therefore, you might not uh, appreciate the importance of this step. But when you go for complex projects, it takes a lot of effort to just study and understand the drawing. Okay. It takes a lot of effort. For example, if you are doing some industrial type of buildings which have lot of machineries and lot of inputs that you need to correctly understand, and there are a lot of levels, lot of different elevations, sections, etc. So at that time it takes long time to study the drawings. Okay, so studying the drawings is going to be extremely important. So how do we study the drawings? Of course, by looking at these in detail. One way to very well study the drawing is, what technique I use is that I assume that I am just walking through this plan. Okay, whenever I am studying any drawing, what I do is I assume myself to be walking, let us say, through this plan. What it means is, let us say that I will imagine myself to be standing over here, and then I will imagine that I'm moving here, I am moving up the staircase, or I am moving inside this, whatever, I am going here. So I try to imagine it this way, that I am having a walkthrough. These days we call it as the walkthrough, isn't it? So I imagine myself to be having a walkthrough through this plan, and that helps me to get a better idea. So that is the technique I personally use. You can use whichever way you want to adopt for studying the plan, but studying drawings is extremely important. All right. So let us see, let us study the drawing before we can move ahead. So this is the plot. Is this AutoCAD drawing visible? Yes. What I will do is, just wait. I will send this drawing in the group so that we can look at it together. Okay. I am going to stop the sharing, and I will put this drawing on the group so that simultaneously all of us can have a look at the drawing. I hope all of you have AutoCAD with you ready. So I am sharing this drawing. Yes. Yes, the drawing has been shared. In the WhatsApp group for the time being. I will put it on the portal also. For the time being, it is on the WhatsApp group. So did you, I hope all of you have received the drawing. Yes, no? Yes. Okay. So open it up. Yeah, for this program, please join on a laptop. Okay, don't watch the sessions on mobile, because you may have to open the software, you may have to refer to multiple programs. So therefore, do not watch the sessions on mobile. Try to attend them using a laptop, desktop, computer, whatever. And have a mouse and calculator and pen, paper, whatever ready with you. So now I hope you all have drawings in front of you. Okay, let us study this plan. First of all, what type of plot is this? What type of plot is this? Hello. So this is actually a corner plot, isn't it? This is a corner plot. So you see you can see these are the two roads. These two roads are meeting over here, and uh, this is the corner that is forming. So this you can call it as the corner plot. All right. It is very important whenever you study a drawing. It is very important to note the directions also. Direction means the cardinal directions, north, south, east, west. So where are those directions? Let us try to see where do you have the direction. So generally every drawing will give you the orientation of directions. So it is like this. Can you see this? So this is the direction orientation: north, south, east and west. So if I just put it over here, so our directions are, the north is facing slightly this side. Of course, this is going to be south, and this is going to be east, and this is going to be west. Actually, it is not like this. It is more towards this side, north. This is south. This is east and west. Okay. So you can easily see the directions mentioned in the drawing itself over here. Good. So this is the corner plot. Some people were telling me, if you people are aware of Vastu, then these types of shapes are not, I would say, conducive with respect to Vastu, isn't it? This type of a plot shape is not very well suited uh, as far as Vastu Shastra is concerned. So I don't have much knowledge of Vastu Shastra. Those of you who have this knowledge, perhaps they will appreciate or they will agree with this fact. So therefore, in such cases, what is the way out when you have this type of a plot? What is the way out? That you build on this type of a rectangular portion. So this was, I also came to know this thing last week when I was discussing this plan with somebody else. So they were telling me about the concepts of Vastu that are involved, that because this is a plot shape, irregular plot shape like this, these are not very desirable as far as the Vastu concepts are involved. So therefore, what is desirable or what is preferred is that you leave out the irregular portion, you leave out this triangle from any construction, and you limit your construction in this portion. So this is what they have done. Is it clear? Hello. No, so I will confess that I am not an expert, or I'm not even proficient at Vastu concepts, but this is what I came to know. So I'm just passing on the information. But I mean, because I don't have enough study, I cannot say whether it is correct or false. All right. Anyway, so this is the plan. Now let us see the entry is from here. The entry they have taken is from this side. So you can see this is the entry gate. This is the point from where they will enter. So this is the entry point. Now this will be, what do we call this portion generally? This portion will be generally called as what? So this portion we generally call it as the porch. Okay. This portion we will generally call it as our porch. So you can see the porch being written over here. There is a parking that has been provided. So they have indicated 2 cars that can be parked back to back in this porch. So because this is a corner, I think you may not be able to park your vehicles outside because of the flowing road that is being shown. So there has to be sufficient space to park your vehicles, cars, two-wheelers, whatever. So they have provided this space, one and two vehicles. Of course, you all know that why can't I have my building line, or why cannot I construct my structure right till this point? Yes, anyone? Why cannot I construct my structure right till this point? Why cannot I have my building still here? Because of some MOS requirement, or what we call as the setback. Okay. So there are some building bylaws. There are some BYE bylaws. So the building bylaws have to be followed, and there is a setback. So the two terms that we use is setback, or you might have heard about marginal open space. Have you heard about MOS? So MOS means marginal open spaces. All right. So you have to leave some marginal open space or setback. So these depend on the building bylaws. So there is a town and country planning department that every, let us say, every city will have under the municipal corporation or under the development authority of your town, city, wherever you live. So that is the statutory authority that decides the rules. Okay. So there has to be some there has to be some setback, or there has to be some marginal open spaces. Again, these marginal open spaces depend on what? So let us say I have this plot. Let us say this is my plot area. So what decides the marginal open space? Let us say this is my built up area. If this is my built up area, what will decide the spaces that I have to leave? What will decide this? Yes, tell me. So this, I can call it as the setback, or I can call this as the marginal open space. So generally this is decided on the basis of your plot size. So number one is your plot size. Your plot size will decide how much open space you have to leave. Then there is a so for smaller plots, you may not have to leave the side spaces, isn't it? As per the plot size, for smaller plots, you may not have to leave the side space. You just have to leave the space at front and back. I'm calling this as the front right now. Let me just clarify. So I'm calling this as the front, this as the back, and I'm calling this as my sides. So based on plot size, you may not have to leave side setbacks, or side setbacks may not be required. You may have to just leave the open space at front and back. For certain plot size, you will have to leave open spaces on all sides. Okay. You will have to leave the open spaces on all sides. This is the first criteria to decide the open spaces or setback line. The other criteria, as Srinivas ji has mentioned, is the road width and the designation of road. Okay, road width and its designation. Designation means whether it is a interior road, or it is a highway, or it is a state highway, national highway, major district road. That also decides the open space that you have to leave. So depending on the road width and the designation of your road, this open space or setback line may have to be decided. Megha is saying depending on the building height. I am not very sure about this point, that whether building height also decides how much open space has to be left. I am not very sure on this. So if someone can just add for this, does the building height decide how much open space has to be left? Anyone having any idea? Because I am not very sure, so I cannot comment. Okay. I will try to find out in the town and country planning rules. But okay, Srinivas ji is saying yes, building height also decides what open space has to be left. All right. Okay, good. So these might be some of the factors which decide how much open spaces have to be left. In India, actually, if you see in our country, we have a, a very strict and almost, I would say, impractical MOS requirements that are given, isn't it? Those are not very practical MOS requirements, and the floor area FAR, the floor area ratios. Floor area ratio means depending on plot size, how much area you can construct. So those FAR requirements in India are very impractical. To my what I feel is that these FAR ratios in India are very impractical, and it does not allow us. These FAR ratios are so strict that they do not allow us to grow vertically, isn't it? They do not allow us to grow vertically. So on one hand, we will complain that, oh, Dubai has so many tall buildings, or let us say New York has so many tall buildings. On one hand, we complain like this, and on the other hand, if you see, we have so impractical FAR ratios that we are not allowed or we are not able to construct, let us say, more than G+5, G+6 in most of the cities. So in the city where I live, where we live, on our major roads of our city, so we live in Indore in central India. So in the major roads of our city, the FAR ratios are such that we are not able to construct more than G+4, isn't it? So on one hand, we talk about vertical development and we compare ourselves with Dubai, New York, Shanghai, etc. And on the other hand, we have so strict and so impractical FAR ratios. So that actually needs to be looked into. If you happen to visit Manhattan, for example, has anyone been to Manhattan, New York? Okay. So if you ever go there, you will see that they don't leave any marginal open space. They don't leave any marginal open space. So if their plot is like this, for example, if this is their plot, they will, construct it on the entire plot, almost on the entire plot, they will construct without leaving any marginal open space, or whatever they leave is extremely, I would say, negligible open spaces that they leave. And they will have a floor area ratio of, I don't know, 100, 50, 60, that kind of FARs they will have, isn't it? So these FAR requirements are impractical in India, if you see, isn't it? And because they are impractical, all of you know that they are basically flouted. Flouted means what is the meaning of flouting? Flouting means the rules are broken, basically. The rules, the FAR norms and the MOS rules are not followed, isn't it? So they are not followed in India, if you see. So what do you do? There is a standard practice that we adopt. What is the standard practice that we adopt? So what is the practice that you will see people adopting? Most of you would be aware that we will have two sets of drawings, isn't it? Have you seen or have you heard such type of thing? So people will generally have two sets of drawings, isn't it? One drawing or one set of drawing will be, let us say, for acquiring permissions. So this will be to take the necessary permissions or approvals. So this they will use for taking permission. So this will follow all the rules and procedures and norms, whatever. And then the actual drawing, will not follow the drawing which has been approved, isn't it? So approved drawing is kept aside, and in the actual drawing, you will break the rules of FAR, you will break the rules of MOS, etc. So that is a much, I would say, that is unfortunate, but that is what is reality. That is the adopted practice you see everywhere, and there's a reason to it. See, the land rates are so high, and these MOS and FAR rules are so stringent that it almost makes it impractical, isn't it? So the TNCP authorities, the town and country planning authorities, the municipal authorities need to look into these aspects uh, thoroughly, isn't it? Okay. Anyway, so therefore, what you see over here is that the entire construction has not been taken till this point. Okay, so you have not constructed in this region. You have left some open spaces on all sides. So that is the statutory requirement. Therefore, you have to leave these open spaces. So you can see open space at the back. You can see the open space on side. You can see the open space on front. And of course, the reason for leaving this large open space, as I told you, were some reasons due to the Vastu. Let me use the spotlight option over here. So this open space that you see over here, this has been left because of the Vastu consideration. All right. Otherwise, you will see the open spaces on sides, front, and at the back. For this plan, let me just clarify. I would be calling this as the front. I would be calling this as the front. I would be calling this as the back. Okay. I would be calling these as my sides. Is it clear? Okay. So now let us try to see this plan in greater detail. So to study the plan, as I had suggested, the technique that I use is that I assume that I am walking through this plan. Okay, what is called as a walkthrough. So I imagine myself as moving around and then observing all these spaces, and then this is the way I try to imagine. So we will try to do that. Let us see. So this is the porch. This porch will be generally covered with what? So you will have a concrete flooring and you will have paver blocks. So you will have a paver block paved flooring over here in the porch. So this symbol that you see, this symbol is usually used for paving. Okay, so you will use your paver blocks over here. This is your porch. Then from your porch, Megha is asking, when corner plot side is also front. No, she is saying when corner plot side is also front. Yeah, very good. So you will have two, whatever, road facing front sides, whatever you want to call them. But for our discussion, we would be calling this as our front side. Okay. For ease of our discussion, I would be calling this as my front. I will be calling this as my front. This will be my side and back. Okay. Yeah, of course, because this is the entry and this is the road. In this case, this is the road and your entry is from this side. You may call this as the front side also, but it's okay. For my discussion, I would be using this convention. I would be calling this as the front side, front, side, back. Okay. Good. Let us go deeper and let us try to understand more about this plan. So you have your porch. This is the porch. Then you enter into this veranda. Okay, what these two lines suggest, these two lines that you see over here, I am using my spotlight function. What are these two lines suggesting? So these two lines are suggesting that you have steps. Okay, these two lines are suggesting you have steps. How many total steps you can see? How many total steps you can see? So you can see two steps, first step, second step. Why do you require steps? Why do you require the steps? Yes, why the steps? Yeah, of course. So we require the steps because we would like to have our uh, floor level. We would like to have this ground level. Sorry. So we would like to have this level slightly above the ground level. So if I call this as the ground level, if this porch area was my ground level, I would like to have my building slightly raised. We call this as the plinth level. So what is the technical name for this? We will call this as the plinth level, plinth. And this I will call it as the ground level, or I will use another term, finished ground level. Okay. Why do you want your plinth level to be raised above your finished ground level? Why do you want your plinth level to be raised above the finished ground level? Hello. Yes, why this? Why do we want our plinth level to be raised above the finished ground level? Because of obvious reasons, because of proper drainage, as Mr. Kashyap is saying, because of proper drainage of rainwater, storm water. Mostly the reason is storm water. That the storm water means when there is rain, the water should not enter our house, isn't it? So we want it to be slightly raised above the finished ground level. So our plinth level would generally always be higher than our FGL or finished ground level. Now over here you will see another level. Over here you will see another level, and that is actually your road level, isn't it? So you will see now that here we are talking about three levels. This is your road level. This is your road level. Now you have your road level, you have your finished ground level, and you have your plinth level. So there are now three levels that are in contention. Most of the times you will see that you try to raise, or you try to raise your FGL above the road level. Listen to this carefully. So you will try to raise your FGL or finished, I'm calling finished ground level as FGL. So usually you will try to raise this FGL above the road level. Why so? Why do I want a raised FGL with respect to my road level outside? So because I don't want the, because see, a practical problem that we have is that most of our roads do not have proper stormwater drainage systems, isn't it? The proper stormwater means when rain falls, whatever water flows as a runoff, that has to be properly taken to designated places. Okay, so that is called as the stormwater. So most of our roads do not have proper stormwater systems, stormwater runoff systems. So what happens is that many times the stormwater may enter your house, or at least it may enter your porch. So therefore, what you want is that your porch level or FGL level should be raised above the road level. Am I making sense? Hello. So if this is my road level, I would like to have a raised FGL. Okay, are we clear? Yes, another important point over here, what Srinivasji is saying, that what many time happens is that when roads are new roads is constructed, okay, it is a wrong practice, but many times what happens is, let us say now this was the old road. Now let us say the repair work has to be done or a new road has to be constructed. So in most of cases what happens is that they will just put a new layer on this, isn't it? Have you observed this type of a thing happening in your cities? So many of the times what they do is that they will just put another layer on the top of existing layer, isn't it? So what happens, earlier your road level was here, now your road level becomes, or your road level reaches to this level. Are you with me? Hello? Yes. Then maybe the next time the road gets repaired, again they will just put a new layer on top of this. So now your road level goes above your FGL. So now every time the rain falls, the storm water very easily enters your porch. This is a very common problem that you see, isn't it? Therefore, what we try to do is that we try to take some contingency to begin with. So whatever is your road level, let us say you will try to maintain from the very beginning, you will try to maintain some gap or some level difference between your FGL and road level, so that even when roads are constructed and their level goes on increasing, still your FGL remains above the road level. Okay, good. This is one point. Now above this FGL will be our plinth level. So our plinth level that you see over here, this plinth level, that will be even above the FGL. So this is my plinth level. Okay, so now we are talking about three levels. This was my road level, this was my FGL, and above FGL I will have my plinth. Any confusion? Hello? Any confusion to anyone? Very good. No confusion. So now, when a person is going to walk from this porch to this veranda, this is the veranda they are calling. Veranda means an open space. It's a Hindi word, or it's a general word used in almost all the Indian languages. Veranda means an open space. So when a person is walking from the porch and coming to this veranda, how many steps the person has to walk? So the person has to walk how many steps? 2 steps, isn't it? 2 steps means how many risers? How many risers can you see? There are 3 risers, correct? So this is 1 riser, 2 riser, and 3 riser. Considering a standard riser of 150 mm, considering a standard riser of 150 mm, what is the plinth height? If let us say this was 0 0 level, if this was 0 0, if this was 0 0 level, I am calling my FGL as 0 0. This becomes how much? My plinth level becomes plus 45. I am talking in meters right now. So plinth becomes plus 0.45, isn't it? Considering all risers are 150 mm, there are 3 risers and therefore 450 mm. So usually your plinth would be 450 mm. That is a standard practice that is adopted to keep your plinth height 450 mm above your FGL. Okay, almost all the bungalows, all the construction that you see, this FGL is adopted. Okay, all right, good. So we reach our veranda level. So from porch I climb the steps, 2 steps, 3 risers. I reach the veranda. Then you can see an open garden, open lawn in front of me. Now this lawn will be slightly at a lower level, isn't it? This lawn will be at a lower level. So you can see this one step. Perhaps this is not a step that they are trying to indicate. So you will have a one step and then you will reach your lawn level. Why has the lawn kept at a slightly lower level than the plinth level? Why is this lawn at a lower level than your plinth? I think you will have 2 steps again, I believe. One step, 2 step, or one step. Yes, why so? 2 steps. Why your lawn is kept at a lower level? So if this is plus 0.0, this becomes 0.45. And now you are climbing down to one step, 2 risers. So let us say you reach what level now? Hello. What level will you reach? What will be the level of this lawn? So level of this lawn will be 0.15. Okay. I hope this is clear. Now this was one step, but I think these are 2 risers that you can see. One is this riser, one is this riser. So 300 you are going down. So if this was plus 0.45 meter, this level becomes plus 0.15 meter level. Remember, this is with respect to some. Mr. Virat is saying 0.3 and Mr. Shreyas is also saying 0.3. Yeah, right now, correct. What confusion I also have is that whether these are 2 risers that they are indicating or whether it is just one step that they want us to go down. Okay, so that will basically decide what is the level of this garden. Typically, I believe that generally whatever I have seen till now, you will just provide one step to reach your garden, isn't it? So yeah, I do agree with what Mr. Virat and Shreyas are saying, that this should indicate only one step or one riser, and this should be 0.3. This should be 0.3. Yeah, I also think it should be like this. That is the confusion. Yeah, 2 risers means two. Yeah, I understand 2 lines means 2 riser. So by that it should be plus 0.15. But my confusion is that generally from whatever you see, usually the practice being adopted, that your lawns are one step below your plinth level, isn't it? It's very rare. It's very rare to see them to be 2 steps below the plinth. That is, I'm talking from my personal experience of whatever I have seen till now. So therefore, the reason for this confusion. As per this drawing, it is showing 2 lines. So 2 lines should indicate 2 risers. All right. But from our general experience, I'm telling you this. So this thing we need to clarify. I will do that clarification and I will tell you. Okay. So as right now, let us go by this drawing, whatever the drawing we have. So 2 lines means 2 risers, and therefore this will be 0.15. Is it clear? I hope I have made myself clear. Hello. Yes. So this is my open. Yeah, 0.15 from the FGL, of course. This is 0. See, this is 0.45 plinth. From plinth, I am climbing down 2 risers. So I'm climbing down 2 risers means I have to subtract 0.3 from the plinth. So therefore, I come up to this level 0.15, isn't it? Clear. Very good. So these are the 3 levels till now that we have worked out. Let us move ahead and see what other things we have in this plan. We are discussing this plan in great detail because we need to thoroughly understand this plan. So now we have a veranda over here. From this veranda, this indicates a door. I can enter inside this door and I enter a lobby. Try to imagine that you are walking in this space. Okay, try to imagine that you are walking inside and you are looking around at all these spaces. Try to imagine it in this way. Okay, so you enter from here. This indicates a door. So from this door you reach a lobby. This is going to be a central circulation lobby. Okay, now this is a door to go to the bedroom. Are you able to see this plan clearly? I hope you have the AutoCAD drawing with you also, isn't it? Yes. So you enter this bedroom. From this bedroom, there is this walk-in closet. These days, in big bungalows, you see this concept of walk-in closet. So walk-in closet means you can enter this closet. You have your clothes, etc. In this space, and from this walk-in closet, you can directly move to the wash area or toilet. Okay, so basically this closet, this is called as the walk-in closet these days, or walk-in cupboards. Okay, so you can see this walk-in closet over here. So basically, if I shut down this door, I can isolate this space from the bedroom space, isn't it? So then this gives me an easy entry into the toilet, etc. So this type of walk-in closet is a general trend that you see. Okay, so this is the first bedroom that you can see over here. This bedroom, what does these two blue lines indicate? What does these two blue lines indicate? So these indicate window. Yes. So you have a window over here attached to this bedroom. So this window is overlooking your lawn. So you will get a good view of this lawn from the window. You may also be able to see the road. Of course, you will have a boundary wall over here. So road may not be visible, but of course you can have a good view of this lawn, isn't it? So this is your bedroom. This size is 15 feet by 15 feet. So this is the feet nomenclature that you can see. And this is the metric unit nomenclature that you can see. 4.6 by 4.6 or 15 by 15. If I just try to measure this quickly, just let me measure dimension linear. So from here to here. So 14 feet, 11 inches, 1/4, 11 and 1/4 inches. 14 feet, 11 and 1/4 inches. It's as good as calling it as a 15 feet room, isn't it? And in the other direction also, I hope all of you are thorough with your AutoCAD. And this is 15 feet, 1 inch. So I can call it as a 15 by 15 feet room. 15 feet by 15 feet is a good size to have. All right. 15 feet by 15 feet is a good size to have. Generally in flats, these days, if you see, in smaller flats, what would be the room size that you get? Just to have an idea. In flats, if you are living in flats, what is the room size that you have? You have 10 feet by 10 feet or 11 by 10 or 10 by 12 or 12 by 12. That is feet. I'm talking about feet. So 10 by 10 or 11 by 10 or 12 by 10 or 12 by 12. That is the type of usual sizes that you have in flats, smaller flats. So this is a big room if you see. Okay, 15 by 15 feet is a big room. And you have an attached walk-in closet, plus you have a toilet. What does this indicate? Correct. So this indicates a ventilator. This indicates a ventilator. Very important to understand over here. How did you differentiate that this was not a window and it was a ventilator? How could you differentiate that this was not a window but a ventilator? Because of the dotted lines. Very good. So because you see dotted lines over here, generally the convention of drawing is that whenever you have dotted lines, it indicates that this particular object that is being represented by dotted lines, it is not at this plan level. Am I clear? Dotted line indicates that this object is not at this plan level. Clear to all of you? What is the meaning of dotted lines? Hello? Okay. So dotted lines indicate this information. So because this is a dotted line, we understand that this opening is not at this particular floor plan level and it is above this plan level. All right. It is above this plan level. So therefore, this is a ventilator that has been provided and not a window. Very good. So this toilet has this ventilator over here. This is the water closet. What you can see, this is the water closet, this is the wash basin, and this is the shower area. All right. So this you have. Now we come back from the bedroom and we come inside, come back to the circulation lobby. Now from this circulation lobby, there are steps that you have, and the steps indicate up indicates that means you have to start climbing from here, isn't it? This is going to be the first step, second step, and so on. So this is the meaning of up. Okay. And again, now you will be able to understand what these dotted lines indicate. So these dotted line indicates that because see, the level is continuously increasing when you are climbing the stairs. Above this level, you are going above the plan level. So therefore, these are being indicated in the dotted line. Okay. So you have to start climbing from this direction like this. So this is up and this is how you have to climb. So we will go to staircase later on. First, let us try to move inside the house and see what else do we have over here. So from this circulation lobby, we walk into this. Now what does these two blue line indicates? These two blue lines. Hello. So this will be a partition, small partition. Maybe this may be a glass partition. What I understand is that this will be a glass partition, isn't it? An opaque or a semi-transparent type of glass panel you will have in this this zone. So this will be a partition. So there is no wall over here. Okay, talking about the walls, I hope all of you know that this is the wall that has been indicated. Okay. What is the thickness of this wall? What is the thickness of this wall? So the thickness of this wall is in this part of the country where we live, the brick size that we have is a 8-inch brick. Okay. In some places you will see 9 inches brick, but what we get over here are the 8-inch bricks. So you will see a brick wall thickness of 8 inches. Am I clear? Hello. Yes. In some parts, if you go to some parts of country, you will see a 9-inch 9-inch brick. Over here we get a 8-inch brick. So we are seeing 8-inch brick wall. Okay. So this hatch indicates brickwork. This hatch will indicate a brickwork. So you can see that. All right. Now, do you see any difference? Do you see any difference between, let us say, this brick wall, what you can see, this brick wall, and let us say this brick wall? Do you see any difference? Hello. Do you see any difference between these two brick walls? One is this brick wall and one is this brick wall. So what is the difference? So this is one brick thick wall. We call this as a one brick thick wall. Okay, this is one brick thick wall and this is half brick thick. Okay, so this will be half brick thick wall. So if this is 8 inches, if this is 8 inches, we are using this as a 4-inch brick wall. What is the general convention? That all the external walls, yes, most of you are correctly saying this. The convention that we use is most of the external, all the external walls, we will try to have them as 8-inch thick bricks. Okay, let me repeat, all the external walls, I will try to have it in 8-inch brickwork. So to explain, external walls here would mean these walls. This is my external wall. This is my external wall. Wherever I am having external wall, external means which is exposed to environment, which is on the periphery of your structure. All those walls I will try to have them 8-inch thick, and all the internal walls which are not exposed to environment, I may have them in 4 inches. Am I clear? Okay, am I clear to all of you? Yes, but these days, okay, why do we want external walls to be thicker? Why do we want external walls to be thicker? Because of the no, Shruti is saying to get more space. No, I'm saying why do you want external walls to be 8 inches? Virat is saying load bearing. No, our brick walls are not load bearing in this construction. The construction that we are doing is a beam column frame construction, isn't it? So walls are not structural elements, neither the external walls nor the internal walls. None of them is a structural element. Mr. Shayaz is saying security purpose. Yeah, this way but if someone decides to knock off your wall, 8 inches and 4 inches won't matter, isn't it? If someone decides to break down the wall, then it will not matter if you are using a 4-inch or 8-inch. Yes, what Mr. Oves is saying is right, that there are serviceability issues that you have to look into. When your brick wall is exposed to environment, you have to look into the water seepage issues, crack issues, serviceability issues, isn't it? So 8-inch thick brick wall offers you more serviceability with respect to the weather, with respect to rainfall, with respect to seepage, etc. Okay, so therefore you would like to have your external walls as 8 inches thick. But these days, what we see is that to carve out more space in almost all the multi-story constructions, what you see, that even external walls are kept as 4 inches, isn't it? To free up more space, you see that even external walls are kept as 4 inches these days. How it will free up more space? If your walls are only 4 inches, it creates an extra 4-inch space, isn't it? So if this was 4-inch, you are able to free out more space. So therefore what happens is that these days the construction is that even your external walls are kept as 4 inches, and this happens mostly in commercial buildings, in multi-story apartments. This is a practice that is being adopted these days, and because of this there are many serviceability issues that you face in apartment buildings, isn't it? Okay, anyway, so going back to our plan, right? So this is the glass partition. Then you will enter. This is your living room. You have some furniture arrangement over here. Then you have your sofa set being kept over here. This is a television, maybe a place to watch TV and all this. Then you have a dining space which is separated from your living room space, isn't it? So just a minute, what is the time? Let me just check the time. Okay, it's 10:10. So I can continue for 10 more minutes very quickly. So this is my living room. Then I have made a segregation of space, and I have this dining room. So here I have not given a wall. I may have a wall, or I may have some furniture item over here to have this segregation between the spaces, isn't it? Maybe I have a 4 feet, 5 feet kind of a furniture, some showcase, etc. at this space. So this creates a segregation between this living room space and the dining space. Okay. Then attached to this dining space is our kitchen. Again, if you see, this kitchen is not segregated from the dining by wall. There's no wall over here. Okay. What you have is a counter that you have provided over here. So this is a furniture counter, and there is no wall over here. So yeah, correct. This can be called sort of an open kitchen. Okay. Not exactly open kitchen, but yeah, you can call this as a as an open kitchen. Okay. Uh, right. Going back, our living room space is 13 by 22 feet, 22 and a half feet. A big living room you have. The dining is also very big, 14 by 22 feet. Big spaces you are having over here. Then we come to our kitchen. It's a 13 by 16 kitchen. Again, big space. And you have a space to keep electrical equipments. So in your kitchen, you have two spaces. One is this space to put your electrical equipments, maybe like a cooking range or microwave, or I don't know, dishwasher, whatever. And this is your kitchen space. Okay. So all these are your kitchen counters, cabinets, etc. You have a place for refrigerator, fridge. You have this gas for stove gas. This is your sink. I hope you are able to understand this. Hello. Yes. Then you have a wash space at the back where you can wash your utensils, or you can keep some extra items over here at the back. So you have a wash space over here. Again, these dotted lines, they indicate that you have a sort of a window, not at this level, but at a level higher than your general window level. So these two dotted lines indicate that. What is this dotted line indicating? So this indicates a chhajja. Okay, this indicates a chhajja. I don't know what is the English word for chhajja. Sunshade. Very good. So Mega is providing us the English word for chhajja. So this is called as the sunshade. But in most of the Indian languages, we use, or we call this as a chhajja. Okay. So this provides protection against sun and rain. Okay. So this has been provided over here. At the back, you have your washing area. So maybe to wash your utensils, etc., whatever. Then you have a storeroom to store your extra grocery, extra items. There is a storeroom that has been provided. This storeroom is a dedicated storeroom for the kitchen. Okay, there are a lot of things you have to store: food grains, vegetables, whatever. So you have a store over here. Then coming out of the kitchen, coming over here, all these are windows that you have provided, big spaces that you have provided, window spaces. So one is this window space, second window space, third window space, fourth window space. So a lot of windows on this side. All right. Then from this dining, you have this attached toilet. So this is called as a powder room. What is the meaning of powder room? Yes, what is the meaning of powder room? Hello. Yes, anyone? Powder room. So powder room generally means, I'll tell you, powder room means the toilets which do not have a shower facility attached with them. Okay. So the toilets, for example, this is your toilet. You don't have a shower facility. You just have a water closet and you have a wash basin, but you do not have the facility to take a shower. So those types of toilets are called as powder toilets. Okay. Dry area, dry toilets, powder toilets, what Lakshmi is saying. Okay. So this is a powder room. So this powder toilet is basically for whom? Generally, this powder toilet is meant for whom? So generally, it is for the outsiders. Yes, for the guests who are visiting your place. So it is meant for outsiders or guests. Okay. Because the people who are living in the house, they will go to their own bedrooms or they will go to their own spaces. So these powder rooms are generally meant for your guests and people who are visiting you. So they are not going to take a shower. The guests usually will not take shower at your place. So guest, by guest I mean those who have just come to visit your house for 1 hour, 2 hour, like that. People who are going to stay at your house, you will have some guest rooms for them. All right. But this is a powder toilet just for people who are visiting your place for 1 2 hours. For them, you have provided this powder room. Good. Then you have a storeroom over here. So this powder room access is from this side. The access to this powder room is from this side. All right. Okay. Coming out of this dining area, then going over here. If you cross this living room, you have a bedroom. This is the second bedroom that you have at this level. Again, a big bedroom, 13 feet by 18 feet. This is the bedroom. You have a big window for this bedroom as well. And then you have again another attached toilet. This also has a walk-in closet and it has an attached toilet over here. Okay. There are ventilators provided to this toilet. The ventilators are overlooking this lawn portion. Oh, all right. Coming out of this bedroom, now we have this open space. This is called as a patio in modern architectural terms. This is called as a patio. Patio means an open space which is overlooking the garden or lawn. All right. So this is overlooking the lawn. This is space that you have created. So people can sit over here, relax, do whatever you want to do, overlooking this lawn. All right. Very good. What does this indicate? These three blue lines, what do they indicate? So these are rolling doors, rolling shutters, 3-panel shutter, sliding shutter, whatever you want to call it. So typically this would be a transparent glass shutter that you will have, so that you get a good view of the lawn sitting in the living room, and you are easily able to move into the uh, patio, and you are easily able to move into the lawn if required. Right. So this is the living room. Then I think, yes, this is all what we have at the ground floor level. Good. So I think now we are at the end of the time. So I think I'll stop for here. The plan was to give some work before our evening session when we meet again. That was the initial plan. But we could not complete, or we could not reach to a level where I could give you some work for the evening. So it's okay. We will not have some work. Uh, The only work for you would be to study this plan before the evening session. So for today, the only work you will have is to study this plan in greater detail. All right. All right. Anything that you see could have been planned in a better way? Anything that you see that could have been planned in a better way? This space that you see, yes, anyone? Anything you think could have been planned in a better way for this? Just for the ground floor we are talking right now. Srinivaji is saying removing all except the wall. Huh? Removing all except wall means Megha is saying that a puja room should be given, could be given. Yeah, there might, there should have been a space included for a puja or prayer, whatever. Yeah, that is not there. Maybe the client does not wish to have. What else do you think could have been better? So personally, what I think is that personally, there is no privacy to this living room, isn't it? Generally, in your living room, what happens is that these are the rooms where almost most of the time you would be spending, isn't it? All most of your family members would be sitting together in a relaxed manner, and the family time generally happens in this space usually. All right. So personally, my observation was that a person, let us say a guest or a or an outsider who is visiting your house, they do not have any designated space, and directly they come to your living room, isn't it? So they don't have a designated space to sit, and you don't have any option but to bring your guests or outsiders. Let's say those who are visiting you, they have no option but to straight away enter your living room. That is one problem that I see. There should have been some intermediate space which you could have made for the uh, outsiders or guests whom you do not want to invite to your living room. Are you getting this? This is a point that I felt could have been better. The other point that I felt, that this powder toilet entry, what I feel is, powder toilet, remember, the powder toilet is for whom? The powder toilet is usually for your outsiders, people who are visiting your house, let us say for an evening, or they have just come to meet you. So a person who has to use the powder toilet, he or she, they have to go from this lobby, then they will come over here, then they will go from this dining space, and then they reach your powder toilet. So basically they are having, or they, you don't have privacy in the living room, you don't have privacy in the dining space, even your kitchen is visible. So this powder toilet could have been better planned. Of course, these are my personal opinion. uh yeah, this is one thing that I felt. Shruti is saying entrance for the toilet could be from bedroom directly instead of walk-in. No, walk-in is a requirement of clients these days. Walk-in closets is a requirement of client these days, because nobody wants that the closet should be separate from their toilet. Everybody wants this walk-in closet these days, isn't it? The advantage of this walk-in closet is that you can just shut this door, and then you have this entire space for you, isn't it? So you have this as a combined dressing table plus walk-in closet plus toilet. This entire space becomes one when you just close this door. So actually walk-in closets are preferred by clients, those who have space. Anyway, so these 2 points I felt could have been planned in a better way. One was to have some space where your guests could sit, and not you may not have to bring them directly to living room. And second was that this powder toilet could have been planned in a better way. These are 2 points that I had. Anyway, so what we will do, we will stop for the time being. If anyone has anything to say, any doubts, difficulties you have, you may discuss now. Yes. Anybody having any doubt? Mega is saying that the staircase to be shifted. Why the staircase needs to be shifted? No, my thought was that they could have brought this powder toilet to the front. My idea was to bring the powder toilet to the front, and what I was thinking was to bring this powder toilet to the front and maybe take the store to the back. But of course, there would be some other issues that the client may not have been ready with. So that is how they have the arrangement over here. Okay. Yes. Correct. One thing that I should have told you, what is this thing indicating? Can anyone tell me? What is this? What is being indicated by this two cross and then this dotted line? So this actually represents a cutout in the slab above. Good. This indicates, Shruti is asking why this living room sofa is crossed with lines. This indicates a cutout in the slab at the above level. So actually this is going to be a double height opening that will be provided. Okay. So these two lines, that is a standard convention that we follow for indicating openings. So this is my opening line. Okay. And why dotted? Because it is going to be at the above slab level. And this will be the cutout. So basically when we go to the above floor in the evening session, we will see that you will have a slab cutout in the first floor level over here. Clear? Good. All right. Anything else? Okay, so we stop over here. Uh, so now, if there are any questions, you can ask. Mr. Virat is suggesting if we put staircase outside, then we have space for guest room. But then no, see, you cannot put the staircase outside this line. Why? Why you cannot put your staircase outside? Mr. Virat is suggesting to put the staircase over here, I think. Here you want to put your staircase? In lawn area. Yeah, the problem is what? What is the problem? Why cannot I put a staircase over here? Because you remember I have to leave some open spaces all around. So I have to leave some open space all around. I cannot encroach in that open space. So I cannot shift this staircase well to this area. All right. Good. Yeah, one more thing that we should have observed was that we have an elevator over here. Okay. So in spite of this being a G+1, we have an elevator. They have provided an elevator also. Okay. So it's rare to have, sorry. It's rare to have an elevator in a independent G+1 bungalow, but they have provided an elevator, maybe because of the client, yeah, of course, because of the client requirement. So the client is foreseeing the future, that in future they may not be able to climb so many steps every time. So they have provided the provision for an elevator also. All right. Good. So that's all for today. For the first session for today, I don't have much of work to give you for the evening session. Generally, our evening sessions would be interactive sessions where we would be discussing whatever you have done in the day. All right. So in the morning sessions, we will have discussions. Sorry, we will have theoretical discussions. I would be giving you some work. We would be assigning you some tasks. And then in the day, you would have to practice those tasks. And then in the afternoon sessions, we would be more of having an interaction on what were the problems that you faced, on what you were able to do, what you were able to not do. But in today's session, we will continue the discussion on plan itself. All right. So we don't have any work to give you for today. So we will continue with the discussion on the floor plan. And there are some instructions that I want to share. So those instructions we would be sharing you in the evening. All right. So evening we will meet at, actually it would be afternoon, 3:30. All right. All right. So we will continue with this discussion. You have the drawings. What we would suggest you to do is that you study the plan. The plan should be so thoroughly studied. Whenever you are doing projects, the plan should be so thoroughly studied that even if someone wakes you in the midnight, you should be able to tell the entire plan to the person, isn't it? It should be so thorough in your mind. Even only when the study is so detailed, only then you would be able to do the projects properly. Okay, so you have to spend a lot of time thinking about this. All right. Okay, so that's it. Yes, I would be sharing some instructions in the evening session also. We would be sending some messages on the group also about how to access the comprehensive courses that would be added on. Those instructions would be shared in the group, and we would be giving you a demonstration in the afternoon session. Earlier, we were thinking to give the demonstration in today's morning session, but because the time uh, is running out, those instructions would be given to you in the evening and in the over the WhatsApp group. Okay. All right. That's all I have for today. Thank you. We will see you in the afternoon. We will discuss more on this plan. In the meantime, just have a look at this. Have a look at the first floor and have a look at the terrace floor also. That's all. Thank you. Bye bye.